All right, so here's a slightly different Hess's law problem that's going to be a little bit more complicated and require a couple more steps. But let's go ahead and look at this, and I'm going to kind of analyze this the way that I would approach this problem and walk you through it. So the first thing that I'm going to do is I'm going to look at what I have as my reactants in my goal step. So if I look at my first substance right here, I have 1 mole of carbon disulfide. Now, what I want to do is I want to look at my steps and I want to see in what equation do I have that compound. So I'm looking through my steps and what I see is that it's actually in this equation right here. Now, the amounts that I have of this compound are the same. I have 1 mole right here and I have 1 mole right here. The difference between these two is the placement. Right here, this is a reactant, and over here, this is a product. So what that means is that I need to flip this reaction. So I'm going to flip that reaction when I rewrite it. So let's go ahead and take a look at the next compound. So what I have is I have oxygen. Now, notice that oxygen actually appears in 2 different locations. Now, because oxygen appears in 2 different locations, I'm going to assume at this point that it will work itself out because I don't know what equation I need to manipulate in order to get my 3 moles of oxygen. So I'm going to leave oxygen alone and I'm going to move on to my next substance and hope that when I'm done, that I will end up with the answer that I want. So let's go ahead and look at the next one. So I have carbon dioxide, 1 mole of carbon dioxide as a product. And so I look at my compounds or my different steps and I see I have carbon dioxide right here. And I have 1 mole of carbon dioxide as a product in this reaction. So what that means is I need to keep this reaction. I'm not going to change it. So I'm going to keep that reaction. Now, in my last one, what I see right here is I have 2 moles of sulfur dioxide as a product. So I look at my reactions and I see I have 2 moles of, only 1 mole of sulfur dioxide right there. So what that tells me is I need to multiply everything by 2. So I'm just going to put multiply by 2. So I need to multiply everything by 2. Now I don't need to flip the reaction because they're both products. So what I'm going to do is I'm going to go ahead and rewrite these reactions with what I said I was going to do. I'm also going to be changing my delta H's to go along with that. So my first reaction I'm going to keep. So I have carbon solid plus oxygen gas, and I produce carbon dioxide. And I'm going to keep my delta H. So my delta H does not change because I did not change my reaction. You could put the moles there. We haven't talked about that, so either one is fine. Now for my next one, I wanted to multiply it by 2. So I'm going to multiply everything by 2. So now I have 2, whoops, let me go ahead and go back to black. So I have 2 sulfur plus 2 oxygen. And this can produce 2 sulfur dioxide. And I'm going to multiply my delta H by 2. And if I multiply my delta H by 2, I'm going to get negative 593.6 kilojoules per mole. Now my next one I'm going to flip. So my products are going to become my reactants and my reactants are going to become my products. So I'm going to have CS2 as a liquid. And it's going to turn into carbon as a solid and 2 sulfur as a solid. And when I flip my reaction, I need to change the sign of my enthalpy. Okay, so let's start kind of taking this apart, and I'm going to start canceling out things. So let's go ahead and start canceling out what does not, what's in the product and the reactant. So let's see. Notice I have 1 mole of carbon as a reactant and 1 mole of carbon as a product, so that's going to cancel out. I have 2 moles of sulfur and 2 moles of sulfur, so those will cancel out, and nothing else will. So what I'm going to do is I'm going to add together what I have on each side and see if it ends up being my goal reaction. So as a reactant, I have CS2 as a liquid, and notice my oxygens right here. I actually have 3 moles of oxygen. And as a product, I have carbon dioxide, and I have 2 moles of sulfur dioxide. And if we compare this to what I want in my goal reaction, what we see is that it is in fact the same reaction that I originally wanted. So I did everything right to my equation to get my answer. So now what I need to do is just add together all my delta H's to get the new delta H for this reaction. And my new delta H is going to be negative 1,075 kilojoules per mole. And so that is my new delta H. And if I were to look at this, what I see is that this reaction is extremely exothermic, and it's going to release 1,075 kilojoules per mole.